Hello students, today I am going to teach you about current electricity. Concept of charge. When two non-conducting bodies such as glass and silk or ebonite and fur are rubbed together, there is a transfer of electrons from one body to another. The body which gains electrons becomes negatively charged and the body which loses electrons becomes positively charged. Therefore, there are two kinds of charges, positive charge and negative charge. Two like charges repel each other, whereas two unlike charges attract each other. The SI unit of charge is coulomb and it is represented as capital C. Charge on a body is denoted by the symbol Q. The quantity of charge on a body is determined by the number of electrons in deficit or the number of electrons in excess. The charge on the body can be given by the formula Q is equal to plus minus Ne, where Q is the charge, N is the number of electrons and E is equal to charge on an electron. The charge on an electron is given as minus 1.6 into 10 to the power of minus 19 coulomb. 1 coulomb of charge means a deficit of 6.25 into 10 to the power of 18 electrons. Now coming on to concept of current. The charge in motion constitutes electric current. Current is defined as the rate of flow of charge or the charge flowing in a unit time through a conductor is known as current. Current I can be given by the formula I is equal to Q by T. SI unit of current is ampere, which is denoted by capital A. 1 ampere is the amount of current flowing through a conductor if 1 coulomb of charge passes through it in 1 second. Current in a circuit is measured by an instrument called an ammeter by connecting it in series in that circuit. Connecting positive terminal of the ammeter with the positive terminal of the source of the current and the negative terminal of an ammeter with the negative terminal of the source of current. Current I can also be given by the formula I is equal to Ne by T, where I is the current, N is the number of electrons, E is the charge on one electron and T is the time. 1 coulomb charge is carried by 6.25 into 10 to the power of 18 electrons. So we can easily say if 1 ampere current flows through a conductor, it implies that 6.25 into 10 to the power of 18 electrons pass in 1 second. Current is a scalar quantity and current always flows from high potential to low potential. In a non-conductor, the charge is static, it does not flow, whereas in a conductor, charges can flow due to the presence of large number of free electrons. Coming on to the next technical term, that's potential difference. The potential difference between the 2 points is equal to the work done per unit charge in moving a positive charge from one point to the other. And it can be given by the formula V is equal to W by Q, where V is the potential difference, W is the work done and Q is the charge. SI unit of potential difference is volt, which is represented by the capital V. V for potential difference, V for volt, and even for voltmeter, the symbol V only is used. The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb charge from one point to other. Potential difference is a scalar quantity and potential difference between 2 points is measured by an instrument called a voltmeter, which is connected across the points in parallel with the circuit, taking care that the positive terminal of the voltmeter is connected to the higher potential. Now coming on to the next term, that is resistance. The obstruction offered to the flow of current by the conductor is called its resistance. R is equal to V upon I. Now this is the basic formula for resistance, where R is the resistance, V is the potential difference, and I is the current. SI unit of resistance is ohm, which is denoted by the symbol omega. The resistance of a conductor is said to be 1 ohm if 1 ampere current flows through it when a potential difference of 1 volt is applied across the ends of the conductor. There are a number of factors which affect the resistance of a conductor. The first one is the material of the conductor. Those substances which have large concentration of free electrons, they offer less resistance, therefore they are called good conductors of electricity. The examples are like the metals, right? Most of the metals, they are the good conductors of electricity. The substances like rubber, glass, wood, etc., which are having the negligible concentration of free electrons, they offer very high resistance to the flow of electrons, and they are called insulators of electricity. The other factor which affects the resistance is the length of the conductor. Longer the length of the conductor, more will be the resistance offered. So we can say R is directly proportional to the length of the conductor. If the length of a wire of the same thickness is doubled, then the resistance of the wire gets doubled. A thickness of the conductor. Now this is a new factor. A thick conductor offers less resistance. That means we can say the resistance of a conductor is inversely proportional to its area of cross section. If radius of a wire of the same length is doubled, then its resistance will become 1/4. The last factor which affects the resistance is the temperature of the conductor. Resistance of a conductor increases with the increase in its temperature. A very common example we can give as the resistance of the filament of a bulb is more when it is glowing due to high temperature in comparison to when it is not glowing, where the temperature is low. Now coming on to Ohm's law. According to Ohm's law, the current flowing in a conductor is directly proportional to the potential difference applied across its ends, provided that the physical conditions and the temperature of the conductor remains constant. We can write it as I is directly proportional to V. Rearranging, we can say V upon I is equal to constant, and this constant is equal to R, which is also known as resistance of the conductor. Here has been given a circuit diagram which is used for the verification of Ohm's law, where a battery, ammeter, resistor, voltmeter, rheostat and key all have been connected in a proper manner with the help of connecting wires. By changing the position of rheostat, we'll find the value of voltmeter and ammeter will be changing, but the ratio of V and I will always be a constant. That means if we keep on changing the rheostat value, we'll find the value of V and A will keep on changing, meaning the value of voltmeter reading and the ammeter reading will change, but the ratio of the potential difference and current will always be same, which will be equal to the resistance offered by the resistor. The ratio V upon I is almost constant, so its average value gives the resistance R of the wire. So while doing the experiment, we can write as R is equal to delta V by delta I, which is equal to slope of V versus I graph. Coming on to VI graph. If we plot a graph for V against I by taking V on y-axis and I on x-axis, it is found to be a straight line graph. And as I've said before, the slope of this VI graph will be giving us the resistance of the conductor. Now coming on to a new term, conductance. The reciprocal of resistance is called conductance. And we can write it as conductance is equal to 1 upon resistance. SI unit of conductance is ohm minus 1. If a graph is plotted for current I against potential difference V, we get a straight line graph passing through the origin, and the slope of IV graph will be giving us conductance. And this graph, if we plot by taking I on the y-axis and V on the x-axis, then this straight line graph, the slope of this straight line will be giving us conductance. VI graph will give us the resistance, whereas the slope of IV graph will be giving us the conductance. Coming on to ohmic and non-ohmic conductors. Ohmic conductors are those conductors which obey Ohm's law. Common examples are silver, aluminium, copper, etc. They are the good conductors of electricity and they obey Ohm's law, so they are called as ohmic conductors. So for such resistors, if a graph is plotted for V against I, it is going to be a straight line passing through the origin, and the resistance R is the same irrespective of the value of V or I. That means the ratio of V upon I is a constant. Coming on to the non-ohmic resistors. The conductors which do not obey Ohm's law are called non-ohmic resistors or non-linear resistances. The common examples are LED, solar cell, filament of a bulb and diode, etc. For these conductors, the graph between V and I is not a straight line, but it is a curve. It is not necessary that the curve on VI graph must pass through the origin. It can pass through any point.